In this video, I want to continue with more examples on quadratics and word problems or problem solving. So here are two more examples. This one says, find two consecutive even integers whose product is 34 more than their sum. So first of all, what am I looking for here, right? So my goal is to find two consecutive even integers. So I have my first integer and I have my second integer. So there's two things I'm trying to find. Now let's review a little bit here. So first of all, even integers, remember even numbers would be like 0, 2, 4, 6, 8, 10, etc. And consecutive means in order. So for instance, 2 and 4 are two consecutive even integers, or 10 and 12 are two consecutive even integers, right? Like 10 and 20 are both even, but they're not consecutive. They're not right next to each other. So when we say consecutive, we mean in order. The way you do consecutive integers is you always let the first one be x or n, whatever you want to use. And then the second one, it's because it's even, we're going to use x plus 2 here. And the reason we use the 2 is not because 2 is an even number. It's because think of the pattern. So for instance, even integers go like this: 2, 4, 6, 8, etc. So if I was looking at the change here, there's always a plus 2 change in between all of these consecutive even integers. That's why the plus 2 is there, is because of the change between them. If it said consecutive odd integers, by the way, so like 1, 3, 5, 7, etc., we actually use the same setup because the change is still a plus 2 change. So that plus 2 comes from that initial change from one to the next. Now, again, as another side note, I only need two values here because it said two integers, but if I had a third one, I would not do another x plus 2. I'd actually do plus 4 this time, because if you're going from 1 and skipping 1, you have a plus 4 change, right? Going from the first to the third one. So it's all about patterns here and how they relate back to the first one. So that's how I set up for two consecutive even integers. All right, so now what do I know? I know that their product, so product means to multiply. So if I multiply them together, it is 34 more than, so 34 plus their sum. And their sum is adding together, right? So x plus 2. So let me talk through this one more time with you. It says their product, so product means to multiply. So I'm multiplying those two integers. Is means equals. 34 more is 34 plus. Now, as a side note, the word than does usually switch the order, but because addition is commutative, it doesn't matter. It only affects subtraction. Their sum. So sum means to add those two pieces. So that's what my equation is going to look like. It's a little bit, it looks like a simple problem right in the beginning, but it's actually kind of a complicated equation. And now I'm going to go ahead and clean this up. So I'm going to multiply through here. I have x squared plus 2x. I don't really need the parentheses here. It's just kind of organizing my thoughts. I see an x plus x, which is 2x, and then I have an extra plus 2 here. So I have x squared plus 2x. 34 plus 2 is 36. So on the other side, I have 2x plus 36. Now, because I'm going to solve this by factoring, I want to get a 0 on one side. I got to bring everything to the other side. So I'm going to bring the 2x over by subtraction. And when I do that, it actually cancels on both sides, which is fine. And then I'm going to go ahead and bring the 36 over. And I have x squared minus 36 is equal to 0. Let me pause for a second. You guys can see my dog Griffin, who came to say hi. He likes attention too. Okay, let's keep going. So I subtract that 36 from both sides, and now I have x squared minus 36 equals 0. And now I can go ahead and solve by factoring. So x squared minus 36 factors into x plus 6, x minus 6. I set each of those factors equal to 0. In the first case, I subtract with 6 and I get a -6. And in the second case, I add with 6 and I get a +6. Now, again, this is one that I do want to just double check and make sure that everything works. Now, keep in mind that I had 2 consecutive even integers. So it's not -6 and 6 are my 2 answers. For instance, if the first one is -6, then the next one becomes -6 plus 2, which is -4. So one combination would be -6 and -4. Or if my first one was +6, then I would do 6 plus 2, which is 8. So 6 and 8 are another potential combination here. Again, it's really important that the setup is really helpful to see that, -6 and 6 are not the answers. They are a part of the pairs of 2 different answers, right? So one set of consecutive even integers is -6 and -4, and the other is 6 and 8. So now let's check and see if they both work. Again, it doesn't say anything that they don't have to be, positive or negative or anything here. So let's see if it actually works. So in the first case, we're looking at their product, right? So multiplying them together. So if I do -6 times -4, is that 34 more than their sum, right? So their sum is adding these together, -6 plus -4. So this is 24 equals 34 plus -10. So that works out, right? So it does work out. And then for my second example, let's check 6 and 8. So if I multiply 6 times 8, is that 34 if I add it to 6 plus 8? So that would be 48. 6 plus 8 is 14. So this actually works out as well. So both of these combinations do work here. So one pair that works is going to be -6 and -4. And another pair that works is going to be +6 and 8. All right, one more example here. Again, we'll do another geometry one. This one says to find the lengths of the sides of a right triangle if the lengths can be expressed as 3 consecutive integers. So first of all, a couple things to remember here. What is a right triangle? So the symbol we typically use for a right triangle is like this little square in the corner, and it means that it is a 90-degree angle. So that those 2 pieces here are perfectly perpendicular. So they meet really perfectly at 90 degrees. So think about like a wall meeting a floor, for instance, if they were built perfectly. So you have a right triangle here. The other thing we have to bring in, which is not explicitly stated in this problem, is that you'd have to use what's called the Pythagorean theorem here. Now, this is something you probably saw maybe in middle school or high school, but it may have been a while. And what it says is the following. So when you have particularly a right triangle, if you square all the sides, you can add the 2 legs, and that would equal the square of the longer side. Now, that longer side is called the hypotenuse, by the way. It is always the longer side or the longest side of the right triangle. And it's also always across from the 90-degree angle. So if you're like, well, how do I know which is which? The hypotenuse is always the longest side, and it's always the one across from the 90 degrees. So that's how you know what to put where. The other 2 sides we typically just call legs. So you may hear that language as well. So the first thing I'm going to note here is I need to find the lengths of 3 sides, right? Because it is a triangle. So even though it doesn't say all 3 sides, it's implied here. So our goal is to find the length of all 3 sides. All right, so let me just scroll this down a little bit. There we go. All right, so we have the first, the second, and the third. Now, the other thing I'm going to note here is that it does say that they are consecutive integers. So remember, consecutive means in order. So for instance, like 1, 2, 3, 4, 5, 6, etc. So in order. The way we do consecutive is the first one starts with x, like we saw in the last example. But because it's consecutive, just regular, not even or odd, look at the change. So I'm adding a +1 in each case, right? Just a +1 from integer to integer. So our second value is going to be x plus 1. And then the third value will actually be x plus 2, because if you're going up 2 spots, right, from 1 to 3, you're going +2. So that's why, because we're always comparing back to the first one. So when we do consecutive, it's all based on the change from the first one. So to go to the second number, you add 1, but to go to the third number, you'd have to add 2. Now, the other thing you have to keep in mind is which side is the longest. And it's going to be the third side. This is our C, our hypotenuse, because x plus 2 is bigger than x or x plus 1. So how do I know it's the longest? It's because I'm adding in an extra +2, which is bigger than the original number or bigger than +1, right? If somebody said to you, hey, I'm going to give you $0, $1, or $2, well, $2 is the most, right? So that's why we know that last one is the biggest one out of all of them. So the formula I'm going to use here again is this Pythagorean theorem. This one here can be my A, and this can be my B. It doesn't matter which leg you call A or B. The only one you really have to know is you need to know the C or the hypotenuse. I need to know which one's the longest. And then I'm going to go ahead and take my equation here and plug everything in. So I would have x squared, x plus 1 squared, and then x plus 2 squared. Now this problem is actually pretty complicated because I have to multiply everything out in order to simplify this. So before I can actually really even start solving anything, I'm going to have to go ahead and multiply out. So I have x times x is x squared. Here I have a 1x. Here I have a 1x, and here I have a 1. This first x squared is from this one right here, just coming down. On the other side, I have x squared, 2x, another 2x, and then 2 times 2 is 4. Cleaning this up, I have a 2x squared on the left side, plus a 2x plus 1. On the right side, I have an x squared plus 4x plus 4. And then what I'm going to do is I'm going to bring everything to one side. I'm going to go left here and just do this all at once. So I'm going to subtract the x squared from both sides, the 4x from both sides, and the 4 from both sides. So everything on the right is going to cancel and give me a 0. On the left, 2 minus 1 is 1, so this is x squared. 2 minus 4 is negative 2x, and then 1 minus 4 is negative 3. All right, now I'm going to go ahead and factor. I'm going to use trial and error here, so x squared could just be x and x. Now 3 is just 1 times 3. So in order to get a negative 2 and a negative 3, I could use negative 3 and plus 1 here. So that would give me the minus 3 when I multiply out and the negative 2x in the middle. And then what I do is I set each of these equal to 0. And I'm going to move back over here because I'm running out a little bit of space. So I would have x minus 3 equals 0 and x plus 1 is equal to 0. Here I add 3 to both sides, and here I subtract 1. Now, keep in mind here that our values represented one of the sides of a triangle. So this negative 1 just doesn't make sense here. I can't use that answer. I can't have a side be length negative 1 anything. So that doesn't work. So the first side has to be 3 then. The next one would be 3 plus 1. So 3 plus 1 is 4. And then the last one would be 3 plus 2, which is 5. So the lengths of my triangle sides are 3, 4, and 5. Now, they didn't tell me if I was using feet here or meters. There really wasn't much context given, so I don't really know beyond that. But I do know that one side is 3 units, one side is 4 units, and then the hypotenuse or the longest side is 5 units. So here's an example where we just we have consecutive rather than consecutive, even or odd, and we're applying geometry in that case.